Hi guys, welcome to lesson 6.6, solving systems of inequalities by graphing. Our objective for today is to be able to graph the solution set to a system of linear inequalities in two variables as the intersection of corresponding half planes. All right, so a system of inequalities is two or more linear inequalities relating the same variables. All right, and the solution of a system of inequalities is any point that satisfies all of the inequalities. And when it comes to graphing, this is the overlap. And as we get started, you'll understand what I mean by overlap. All right, so problem number one is going to be graphing a system of inequalities. So we're going to approach this the same way we did systems of equations by graphing in 6.1. So the first thing, we're going to identify what is our slope. So our slope is -1, and our y-intercept is 5 in our first equation. In our second equation, our slope is 3, and our y-intercept is -4. Now, it is time to graph. Yay! So remember yesterday we said if it was greater than or equal to or less than or equal to, we use a solid line. And if it was less than or greater than, we use a dashed line. So if we'll notice, looking back, both of our equations are greater than or equal to, so they are going to be solid lines. So our first line we're going to graph, I'm going to use black again. So our y-intercept was +5, and our slope was -1. So we went down 1 and to the right 1 each time. All right, now I just need to use a straight edge and connect the dots on that line. All right, now when we look at it, we are the original equation was y is greater than or equal to -x plus 5. So it meant we were going to be shading above. If we plugged in that test point, 0 was going to be greater than 5. So we need to shade the opposite side. So we're going to shade up above here. And your shading doesn't have to be perfect, but it has to be enough to tell which region is which. All right, our second equation was y is less than or equal to 3x minus 4. So we have a y-intercept of -4 and a slope of +3. So we're going up 1, 2, 3, and to the right 1. Up 1, 2, 3, to the right 1. Now you'll notice these don't have a real nice intersection. So unlike systems of equations where we're going to get one point that is our solution, here we're going to get a whole lot of points. All right, now that equation was less than or equal to, so we need to shade below it. And so we're going to shade this section here. All right. Now, we want to look and identify a point in our overlapping section. So somewhere in the middle of where both areas are colored, where we have both red and green. So I'm going to pick this point right here, 5, 5. That's going to be my test point. Now, I'm going to plug that into my equation. So 5 is greater than or equal to -5 plus 5. So is 5 greater than 0? Yes, it is. All right, our second equation, we have 5 is less than or equal to 3 times 5 minus 4. That's 15 minus 4. So is 5 less than 11? Yes, it is. So we have the region shaded correctly. So the solution to a linear system of inequalities is the area that is overlapping in between our two areas, our two lines. So it's the area or the region that has both colors of your shading graphed there. Oh yeah, by the way, you're going to need 2 different colors for this. All right. Let's take a look at a couple practice problems using this skill. We have letter A, y is greater than 3x minus 2. So we have a y-intercept at -2. And our slope is a positive 3, so we're going up 3 and to the right 1, up 1, 2, 3, right 1. And since it is, I'll make a little mark that this is our black line, since this is greater than, it is a dashed line. So just draw a couple dashes on it. All right. Now our second line, well, let's shade this one in first. So we have plug in 0. 0 is greater than -2. Yes, it is. So we're going to shade above this line, so the side that has 0 in it. If you haven't quite figured out yet, when the inequality symbol is greater than, we are going to be shading above the line. And when the inequality symbol is less than, we shade below the line. All right, so we've got y equals -2x plus 5. So we have a y-intercept at +5 and a slope of -2. So we're going down 2 and to the right 1, down 2 to the right 1, down 2 to the right 1. So we have our line that we can draw. Ooh, and what did Mr. Boland do wrong here? Mr. Boland drew a solid line when it should be a dashed line. So make sure you don't fall into that trap and make sure it's a dashed line. All right, so remember I just said a little hint, if we haven't figured it out, is that when it is less than, we're going to shade below it. So you can see our regions. So we can see this overlapped section here that's bordered by the 2 lines and the edge of our graph. This is our solution. So any point in this overlapping section would be a solution to both inequalities. All right, let's start with letter B. So we have y is greater than or equal to -x minus 4. So this is going to be a solid line. The y-intercept at -4. And we have a slope of -1. So we're going down 1 and to the right 1 each time. So we draw in our straight line. All right. And it is greater than, so we are going to be shading above this line. Except for my sloppiness. Clearly, coloring inside the lines was not one of my strong suits in elementary school. All right. Now we're going to graph our second line, which is y is less than -4. So we have a point at -4, and it is a horizontal line, if we remember that from the last unit, and it is less than, so it's going to be a dashed line. All right. And we said y is going to be less than, so it needs to be shaded below. Okay, so our solution set is this area right here. Okay? Want you guys to try letters C and D on your own, and then we'll go over it as a group. So we have y is less than -2x plus 3, so we have a y-intercept at 3, a slope of -2, so we're going down 2 and to the right 1, down 2 to the right 1. It is a less than, so it is going to be a dashed line. So we go dashed. All right. And we're going less than, so it's going to be shaded below. So why don't we switch it up and go to CalBarb Colors. Okay, so that section is shaded below. Our second line, y is greater than or equal to 1/2 x minus 2. So we have a y-intercept at -2. And our slope is a positive 1/2, so we're going up 1 and to the right 2 each time. And we can connect that line. And it was a greater than or equal to, so that's a solid line. All right. And we need to do our shading. So for this one, it's greater than or equal to, so we're going to shade above our line. Okay, so the overlapping black and orange section is going to be our solution set. So letter D, we have a point. We got y equals -3, so we have a horizontal line at -3. Draw that in. And it is less than, so it's going to be a dashed line. All right. And we said we were shading below that because it is less than -3. So we shade down here. Okay. Now our second one is y is greater than or equal to 1. So we have a y-intercept of 1. And we are it is greater than or equal to, so it's a solid dot or solid line. And it is greater than or equal to, so we need to shade above. Now, interesting. I told you guys that the solution to a system of inequalities was going to be the overlapping region, but this one doesn't have any overlapping region. So the answer on this one would be no solution. There is no point anywhere on a coordinate grid that would satisfy these two equations because it cannot be both less than -3 and greater than 1. So this would be a problem where there is no solution. All right, so that is possible with inequalities. All right, problem number 2. Writing a system of inequalities from a graph. So this is where these can be a little bit tricky. So we're going to start with this dashed line, and we see it's got a y-intercept there of +1. And if we look at where we have nice points for it, it looks like it is going down 1 and to the right 2 every time. So that would be a -1/2 slope. So let's start with that. We have a y, we have -1/2 x, and we said we had a y-intercept of 1. All right, so now we need to figure out, is it going to be less than or equal to, greater than or equal to? Well, first of all, I see that it is a dashed line, so that means I can automatically eliminate the two equal to's. And it is shaded below the dashed line, so that means it's going to be less than. Okay, so if we're shading below the line, it's less than. If we're shading above the line, it's greater than. So y is less than -1/2 x plus 1. That is our first line. That is the first one we have graphed there. Our second equation, where we have the same y-intercept, so we can say +1. And if I look at its pattern, it looks like I have a slope of a +1/2. I'm going up 1 and to the right 2 each staircase I take. So it's going to be a +1/2 x, and our variable is y there. So now I got to figure out, is it less than, equal to, greater than or equal to, etc. So I'm looking and I see that it is a solid line. So that means it's going to be one of the equal to's. And it looks like I'm shading below it again, so it'll be less than or equal to. Okay? So letter B, we have, instead of showing all of the regions that are instead of showing all of our regions that are shaded, we're only showing the overlapping region. So we're going to do the same process. We're going to start by identifying our y-intercept. So here we have a y-intercept at -2. And let's figure out what our slope is. So from that point, it looks like I'm going up one and to the right one each time on this solid line. So I would say that slope is 1. So I have my variable y, and we have x, because our slope is 1, and -2, because that's what our y-intercept is. And now we got to figure out where are we shading. So if the region that's shaded here is just our overlapping region, I can see that that is above my solid line, because this is that first line. So the shaded region is above it, so that means I had to be shading above there in order for it to be overlapping. So it's going to be y is greater than, and it's a solid line, so it'll be equal to. Okay. Now, the second line, we have the same y-intercept, so I can put a -2 right away. And it looks like I'm going up 1, but it's all the way over here to 3. So up 1 over 3, up 1 over 3. So my slope for this line is 1/3. So I can write 1/3 x. And I have my y over here. Now I got to figure out what symbol am I going to do. So here is what I have, and it looks like it's shaded below it, so it's going to be less than, and it's a dashed line, so it's only going to be less than. All right, I want you guys to try letters C and D, and then we'll go over both of them. All right, so letter C, let's start with one of these. So I have my point right there that's intersecting, but actually I have a y-intercept that's right up here. That is a little more useful to us than just some random point of intersection. So I have a y-intercept of 3 for this diagonal line. And it looks like we have a point there and a point there. So we're going up 1, 2, 3, and to the right 1. Up 3 to the right 1. So that looks like our slope is a +3. So my equation, we're going to start off, we have 3x, and we have a +3 for our y-intercept. And I have my y value there, because we're just writing these in slope-intercept form. And now I'm looking at it, and it looks like I'm shading above that line, and it's a solid line. So it's going to be greater than or equal to. Okay. My second line, we have a y-intercept there at -2. And our slope looks like we are going down 1 and to the right 1 each time. So our slope is going to be -1x. Our y-intercept is -2. We have our y value, and now I just got to figure out, am I shading above it or below it? Looks like I'm shading below it, and it is a solid line again, so this is going to be less than or equal to. So those are my two equations. Now letter D is asking us, in problems A through C, is the intersection point of the two lines part of the solutions to the system? So if we think about what I said about the definition of a system of inequalities, it was all of these points satisfy all of the equations. And if we remember back to yesterday's lesson where we talked about what a dashed line means the points on that line are not part of our solution set. So if the point is not part of the solution set in one, but it is in the other, is it part of our solutions for the system? The answer is no. One line is dashed. So remember, just like the closed dot meant it was part of the solutions for just a one variable, a solid line means it is part of the solution for a multivariable. Dashed line means it is not. So one line is dashed. How about in letter B? We have one line is solid, one line is dashed. So again, no, one line is dashed. How about letter C? Both of those lines are solid, so yes, any point on the line, including the intersection point, is going to be a solution to both equations. Okay? All right, let's take a look at the next page, which is applying or using a system of inequalities, so real-world type situations. We have a dog walker earns $15 per hour, so we're going to say dog walking is X. She also earns $12 per hour for babysitting, so I'm going to say that is Y. Okay, $12 per hour for babysitting, $15 per hour for dog walking. She wants to earn at least $300 next week, but she can work no more than 30 hours. What is a graph showing how many hours she can work at each job? So, first of all, we've got two inequalities that we can write. So she wants to earn at least $300. So we're going to say $15 times the amount of hours she's walking dogs plus $12 an hour times the number she's working babysitting is greater than or equal to the 300 that is her goal. That's one line. Our second line is that she can work no more than 30 hours. So the time spent walking dogs plus the time spent babysitting has to be less than or equal to 30. All right, so let's, we need to set up some graphs. We need to label things. So we said dog walking was our X. And we said that babysitting was our Y. And we need to put some scales on. So I'm going to go by fives each line. So 5, 10, 15, 20, 25, 35, 45. I'm going to do the same on my y-axis. Okay, so it kind of blends into our equation there a little bit. Sorry about that. So now we need to graph our two lines. So x plus y is 30. Well, if we use our intercepts, since they're in standard form, if we only work walking dogs, we'll have 30 on our x-axis. And if we only work babysitting, we're going to have 30 on our y-axis. And it's less than or equal to, so it's a solid line. All right. And we said it was less than, so we're going to shade below it. Okay. Now we need to graph our second line, our value, our money line. So we're going to find our intercepts for that. So we're going to say 15x equals 300. Divide both sides by 15. Our x-intercept is going to be 20. So we have an x-intercept at 20. And if we plug in 12y is equal to 300, divide by 12, our y-intercept is going to be 25. So we have a point at 20 and 25. So now we can connect these dots. And we said that this was going to be greater than, because she wants to earn at least that amount of money babysitting. So we shade the whole rest of the graph. Yay. So our overlapping region, our solution set, is this weird shape right there. Okay? So if we were to say, for example, walk dogs for 20 hours and babysit for 5 hours, or if we walk dogs for 10 hours and babysat for 15 hours, or we walk dogs for 5 hours and babysat for 20 hours, or we babysat for like 28 hours. Any point within this overlapping section is a combination of hours she could work at the 2 jobs and still make the target amount of money that she wanted. All right. So now letter B. You want to build a fence for a rectangular dog run. You want the run to be at least 10 feet wide. The run can be at most 50 feet long, and you have 120 feet of fencing. What is the graph showing the possible dimensions of our dog run? So let's just do a quick little sketch at the top of the page here. We want a rectangular dog run, length, width. So we want the length, we want the width, sorry, to be at least 10 feet wide. So our width has to be greater than or equal to 10. All right. The run can be at most 50 feet long, so our length has to be less than or equal to 50. Hey, look, I'm starting to look like a system of inequalities. And you have 120 feet of fencing, so that would be the perimeter has to be less than or equal to 120 feet. All right, so let's take all those together. If we say, let's put the length on our x-axis, and let's put width on our y-axis. Okay, so length x, width y. So we're going to say our 3 equations. We're going to have our length is going to be less than or equal to 50.
Joshua Clem, please come to the office of Hearing Wrestling.
Our width is going to be at least 10 feet. So we've got 2 equations right there. Well, let's graph those right away. Y is greater than or equal to 10, so we have a point at 10. And it's greater than or equal to, so it's a solid line. Okay. And we have x is less than or well, here, let's shade that. So if we go with let's go with red. Okay, so we'll just kind of shade that in red so we know that's what we did. All right. Our second one was, sorry, y is greater than 10 is the red one. We're going to do x is less than 50 in green. So we have a point on, oh wait, what did Mr. Bolin forget? Mr. Bolin forgot to put his labels on here. He has them on his sheet, but he doesn't have them on yours. So I'm going by 5s on my x-axis and 5s on my y. Okay, so I've got my labels my axes labeled. So now I've got x is less than or equal to 50, so we have a vertical line at 50, and it's less than or equal to. So we draw in our line, and I'm going to color that in with green. Okay, so we have an overlapping section, but what did I forget about? What limit, what boundary have I not worked with yet? and it's that I have 120 feet of fencing. So I said my perimeter had to be less than 120 feet. So if I say perimeter is 2 times x plus 2 times y has to be less than 120, well, if I say 2x is less than or equal to 120, x has to be less than or equal to 60. And if I do the same thing for y, 2y is less than or equal to 120. So y would have to be less than 60. So I have my points. I have one at 60, and I have one at 60, my two intercepts. Connect those dots. So this is a system of inequalities that has three equations in it. So the region that makes all three true is going to be this one that is shaded in black here. This is an area that has all three of our limits included. So that black section that's shaded there, that is the section that any one of these points will make all three of our criteria true. The run will be at least 10 feet wide. It's higher than 10, greater than 10 feet wide. It is at most, so it's 50 feet long or less. All these are less than 50 feet. And these would use a perimeter of less than 120 feet. All right. I want you guys to try letter C, and then I will go over it. So, cherries cost $4 per pound. Grapes cost no more than, or they cost $2.50 per pound. And you can spend no more than $15 on fruit. And you need fruit 4 pounds in all. So you're making some kind of fruit salad. I don't know. All right. What is a graph showing the amount of each fruit that you can buy? So first of all, let's write our two equations. So we know we need to have at least 4 pounds of fruit. So if we said cherries are x and grapes are y, so cherries and grapes. Don't forget our units. Okay, we are measuring in pounds. All right, so we have cherries, we have grapes, x and y. So the total amount that we buy has to be at least 4 pounds. So x is going to be, or x plus y has to be greater than or equal to 4. That's one equation. Our second equation is our cost. We can spend no more than $15. Well, cherries cost $4 per pound times the number of pounds. Grapes cost $2.50 per pound times the number of pounds. That has got to be less than or equal to 15. All right, so now we need to start graphing some of these. I'm going to first graph our quantity variables. So if I only bought if I only bought cherries, I would have 4 pounds. We should probably put some numbers in. I'm going to go by half-pound increments. So 1, 2, 3, 4, and 5. I'm going to do the same on my x-axis. All right, so we got 1 through 6 on the x, 1 through 5 on the y. And I know that I could buy 4 pounds of cherries. I would have all of my fruit. I could buy 4 pounds of grapes. I graphed those backwards. So 4 to 4, we can connect that, and it's greater than or equal to, so we have a solid line. So I can shade this region with, I'm going to do green. Okay, so anything up here would give me the amount of cherries and grapes that I would need for whatever kind of weird fruit salad recipe we're making. So now I need to solve this equation for my two intercepts. So if 4x is equal to 15, if we divide both sides by 4, x is going to be less than or equal to 3.75. Okay, and if we use 2.5y is less than or equal to 15, divide both sides by 2.5, and y is going to be less than or equal to 6. So we plot, x, wait a minute, I have these backwards. So 2.5 is our x variable. Wait a minute. Oh, I did this wrong. I'm sorry, guys. I made our graph wrong. I needed to have 6 up here for grapes. Okay, so we have y is 6, so there's 6 up there. Y is 6, and x would be 3.75, so that would be right about there. So we need to connect our dots. All right. And now we just need to shade that region in. Okay. And the overlapping section is the section that we would be able to buy. So we would be keeping our cost where they needed to be, and we would keep our number of pounds that we would get where they also need to be. All right. So there we go. And that is our solutions. All right, now I included 4 additional practice problems in your notes that I'm not going to go through at this moment. However, you can check your answers magically right there. So if you want to work through these problems and check your answers, you can. Letter A, we're going to have, I wrote no solution, but there is a solution because we clearly have a section that's overlapping. The red line is shaded below, the black line is shaded above. Letter B, we have a region right here that is being overlapped. Letter C, it's going to be this region over here that has our overlap. And letter D, it'll be this region down in the bottom right quadrant and a little bit into the others. Okay, so those are some additional examples. If you want to work through them on your own, you can see the work that I have shown there to solve each of these problems, and you can do those on your own if you would like. All right, so make sure you rate your level of understanding, 1 through 4. Write down any questions you may have come up with, and please write a summary for this lesson. All right, this is your last lesson in Chapter 6. It's also the last lesson in the first semester. We will be having a quiz coming up over these inequality units, and we will be getting ready for the final pretty soon. So have a great night, and we will see you in class.